Welcome to LINQToObjects Part 2, Querying an Array of Objects. Let's get right to the code. So first we have an instructor class that we've created. We have a private decimal property called monthly salary, and some auto-implemented properties, first name, last name, email. Here is our constructor. We're passing in our values here and setting them. Down a little bit lower, we have a monthly salary property in which we're checking to see if the value is greater than 0. Now here we have M, which represents a decimal literal. D, like that, represents double, but M represents a decimal. Some people say that M stands for money. I don't know that that is where they got it from, but it does stand for decimal literal. And then down below, we're overriding the toString method and creating our own, which will format the first name, last name, and email. So it'll be set in sort of a column format. And then down at the end, we've got currency set for our monthly salary. Then in our driver class, we're setting up an array of instructors that we have set up here. And we've initialized them with some anonymous objects and filled it with these objects calling our constructor. A little bit further below, we're going to use our for each loop that we discussed in the last video to loop through the elements in the unsorted and unfiltered array. Again, our var keyword that we've already discussed. And we're saying for each element in the array called instructors, which we've set up here, instructors, we're going to loop through and we're going to print out to the console the element. And it's going to call our toString method and print it based on our format that we saw in the previous class. Here's our first LINQ query. We're going to get from instructors the monthly salary, and we're pulling it in a range. So notice we have the double and operator here. So it's saying where the monthly salary is greater than 5,000 decimal, that's a decimal literal, and the monthly salary is less than 7,000 decimal. And then we're selecting the element. And finally, we're going to print out the elements based on the results from our query being called between 5K, 7K, which we established up here. And we're going to loop through and write each element to the console again, invoking that toString method. All right, let's see if this will run for us. And here we have our unsorted array. Then once we've run our query, it then breaks out all the instructors between 5,000 and 7,000 and only prints those out for us. You see that it's actually doing that correctly. So we'll close that and we'll write a little bit more code. So our first to-do, no, this is not Toto, this is to-do. Our first to-do is we're going to order the instructors by last name and then first name. So what we want to do first is we want to use that var keyword again and give it a name. So we'll call it sort by name. We're going to choose that from in instructors. IntelliSense pops that up for us. And order by I dot. Now notice, once I hit our dot access operator, it gives me all of the properties from our instructor class, and I'm able to choose what properties or methods that I want to use. So on this case, we want to start with our last name, and then we want to sort them by first name after that. So it'll start by sorting it by last name and then by first name. We'll finish it with selecting the element. Now in order to see, let's get rid of our to-do or todo. In order to see what we have done, we're going to go ahead and loop through our sort by name query results, and we're going to print out our results if there are any results to print out. Now, any is a special method that can be used that returns true if there's at least one element, and it returns false if there are no elements at all. We could use the extension method called count to do the same thing. However, it returns the number of elements in the results. So rather than using any, we could have checked that count was non-zero, but it's more efficient to determine whether there's at least one element than to count all the elements. So as long as there's any elements within our results, we're going to go ahead and do something with those elements. We're going to console.writeLine, call our sort by name again. Now, we have two available options here, first or default. First will return the first element in the results from the query. First or default will return the first element or a default value should the sequence contain no elements. Now, because we're checking to make sure that there are elements already in there, we can use first and it would be just fine. However, I do prefer to use the first or default most of the time because it will return a default value for me should there not be any elements. We can get rid of our to-do and let's run that. See if it works. Here we have our first employee. Once it's been sorted, Jason Bourne. Now remember, it was sorting by last name and then first name. Well, B is the first letter, so it did it correctly. The next thing we want to do is select instructor last names. So again, our var keyword, we'll call it last names. And it's going to equal from I in, no, we don't have to use I. We can call it anything we want. We can call it INST for instructors. The thing is, once we put it in the from clause, it wires it up so that IntelliSense will now work for us. So we'll select INST dot, and we want the last name. Thank you, IntelliSense. This is just going to select our last name from the instructors. And here we want to print out the distinct instructor last names. So we'll loop through. And we're getting this from our last names query. Once again, IntelliSense pops up. Once again, IntelliSense pops up with all of our options. We want the distinct. Now, distinct means it's going to pull back only the distinct values. So if there's two employees, or if there's two instructors, or if there's two students that have the last name Brown, it will only pull one Brown because Brown it will be a distinct value. Here it says it returns distinct elements from a sequence using the default equality comparer to compare values. Basically what that means is it compares the values, and if a value is found to be the same, it will return only one of those. So we're going to print out to the console the element, again invoking that toString method. Now, We're only gathering the last names though. Notice we have only selected the last name. That's all we want to get. So when this prints out, it should only print out the last names. Not just that, but only distinct last names. Now notice we had 2 princes. It only printed out 1. So it did it correctly. Get rid of our Toto. And we'll write our final query, starting again with var. And this one's called names and emails. And we're setting this query equal to, or the results from this query equal to, for I and instructors, we want to create a new anonymous type object. So what this is, an anonymous object, remember, it's a type without a name. We don't actually give it a name when we initialize it. And how we do that here is we say select new, and we use the new keyword, and we'll say I dot, well, here's F name right here. Then we can set a new value here. We can say last equals I dot L name, and then we'll do I dot email. And this is creating a new anonymous type object that will actually have F name and then the name printed out. Then in this position it'll say last with the last name printed out, and then it'll print out email with our email printed out. Finally, we'll come down and we'll write to the console. This will be our names and emails only list. Again, looping through with the for each loop and calling the names and emails query results. I'm going to say console dot write line and print off that element. Let's run it and see what we get. All right. Notice it says F name equals Tony, last equals Stark, email equals tstark@weaver.edu. When we come in here to our instructor class, notice that it replaced the name L name with the name last. And we did that with our anonymous type object when we set the value right here. This shows how you can specify a new name for a selected property. If you don't specify a new name, the property's original name is used. So in this case, F name and email were both used, but last was used because we specified that name. So this query is known as a projection. And the reason we call it a projection is because it performs a transformation on the data. In this case, the transformation creates new objects containing only the first name and last and email properties. Transformations can also manipulate the data. For example, you could give all instructors a 10% raise by multiplying their monthly salary properties by 1.1. If we did that, then we would say new salary equals I dot monthly salary times 1.1. Now notice it's not going to like this. It's not happy with me. I need to add that M, and then it'll be happy with me. So now it's going to loop through, and it'll print out whatever I've asked it to print out. Here it has presented a new salary with a 10% raise. Only it's a little bit difficult to tell because we don't have the names with them. Well, we can remedy that quick enough. We have Tony Stark now has 6,050. Diana Prince now makes 6,160 and some change. So notice here that we were able to manipulate the data or transform it in that new object. One of the great things about implicitly typed local variables is they allow you to use these anonymous types because you do not have to explicitly state the type when you're declaring such variables. They go off of the initialized value. When the compiler creates an anonymous type, it automatically generates a toString method that returns a string representation of the object, which is why when we print this, it prints out with the curly brackets on both sides. This is the toString method that is invoked, that is automatically created by the compiler once we declare the anonymous type. And that's it for part 2 of LINQToObjects, querying an array of objects. Remember, geek is chic.